What if I told you that the strongest concrete ever made wasn't created with modern machines, modern chemicals, or modern engineering, but by the ancient Romans over 2,000 years ago? And here's the shocking part. Modern scientists still can't perfectly recreate it. Before we start, let me ask you, why do Roman buildings stand strong after 2,000 years, while many modern structures crumble in less than 100? What secret ingredient did the Romans use that we no longer have? And how did their concrete become stronger the older it got? Stay with me, because the answers are more unbelievable than you think. Welcome to the channel. Today, we dive into one of the greatest engineering mysteries of ancient history, Roman concrete, the super material that built an empire and still keeps scientists guessing. From massive harbors built inside the ocean to temples and domes that survived earthquakes, this ancient material has outperformed even our best modern concrete. And in this 20-minute video, we're going to explore what Roman concrete was made from, why it lasts for thousands of years, how it repairs itself, why we still can't copy it, and the shocking engineering knowledge Romans had centuries ahead of their time. Let's rewind history. Before the Romans perfected their super material, ancient cities relied on mud brick, cut stone, timber framing. These were strong, but limited. You couldn't build giant domes. You couldn't build huge sea walls. You couldn't build harbors that stood for centuries. Rome needed something more, something new, strong, and flexible. Their empire was growing rapidly, and they needed faster construction, earthquake-resistant structures, materials that didn't crack in salty water ocean, and buildings that could last lifetimes. And then the breakthrough came. Around 200 BC, Romans discovered a natural wonder near Mount Vesuvius: volcanic ash. Not ordinary ash. This ash was filled with minerals that reacted in a very special way. When the Romans mixed it with lime, water, stones, and crushed ceramics, something magical happened. A new form of concrete was born: pozzolanic concrete. Scientists today call it the first super material in human history. But here's the wild part. This concrete didn't just harden, it grew stronger. Yes, Roman concrete ages like fine wine. While modern concrete begins to crack and weaken within decades, Roman concrete does the opposite. Modern engineers recently discovered something breathtaking. Roman concrete contains tiny mineral crystals that continue forming for centuries. These crystals fill gaps, strengthen the structure, and repair microcracks. This leads us to one of the most incredible features ever found in a building material: self-healing. Your roads crack, your walls crack, your sidewalks crack. Roman concrete, it repairs itself. Imagine that. Let's talk about the most impressive use of Roman concrete: harbors built directly into the sea. Today, salt water is one of the biggest enemies of construction. It corrodes steel. It weakens concrete. It destroys foundations. But Roman harbor walls? They've been standing strong for almost 2,000 years, despite waves, storms, salt water, and earthquakes. How? Because salt water actually activates the volcanic ash inside the concrete. Salt water plus Roman volcanic mixture, more mineral crystals form, meaning the concrete strengthens, the walls get harder, and the structure stabilizes. Nature becomes part of the construction process. This was not just engineering. It was genius-level chemistry long before chemistry even existed. The Romans didn't just build with concrete. They revolutionized architecture with it. Thanks to this material, they created the Pantheon, largest unreinforced concrete dome on Earth; the Colosseum, aqueducts, bathhouses, fortresses, giant bridges, harbors, and ports. The Pantheon dome alone is a masterpiece. Modern concrete domes crack. Many collapse. Yet the Pantheon dome, unsupported, massive, perfect, has stood untouched since 126 AD. How? Roman concrete becomes lighter at the top and heavier at the bottom, giving perfect balance. This is advanced engineering, thousands of years before computers. In recent years, scientists used microscopes, scanning lasers, chemical tests, advanced X-ray imaging, and they found something unexpected. Roman concrete is nothing like modern concrete. Modern concrete is simple: cement, water, sand, gravel. But Roman concrete? It's like a living organism. It contains volcanic ash, crystalline compounds, chemical reactions that continue for centuries, minerals that expand inside cracks and seal them. Roman concrete is dynamic. Modern concrete is passive. This is why our buildings fail, and theirs don't. You may wonder, why don't we just make Roman concrete today? Great question. Here's why. The exact volcanic ash they used comes from specific regions, not easily available today. Some parts of the recipe are missing from history. Modern construction relies heavily on steel reinforcement, but Roman concrete doesn't use steel. Modern builders prioritize speed. Roman concrete takes much longer to fully develop strength. The Romans used regional materials with unique chemistry that we don't fully understand. Even with today's technology, modern scientists still cannot completely replicate Roman concrete. It remains a partially lost technology. Imagine buildings that last 1,000 years plus, bridges that don't collapse, harbors that grow stronger, roads that never crack, homes that withstand natural disasters. Roman concrete shows us that the ancient world may still hold solutions to modern problems. Sometimes the future is hidden in the past. Thank you for watching this deep dive into one of the greatest mysteries in engineering history. Before you go, answer this in the comments. Do you think modern technology will ever recreate Roman concrete perfectly? Or is this ancient supermaterial lost forever? I read every comment, so tell me your thoughts. And if you enjoyed this video, please subscribe, like the video, and share it with your friends. It helps the channel grow and lets me bring you more fascinating topics like this one. See you in the next video.